notice, and this is the typical copyright. We are now at section 8, Geometry and Trigonometry. This is the 7th video out of 24 in this section. Especially since I am employing what is known as Vygotsky's principle of scaffolding, which essentially we know better as moving from the known to the unknown, or graded problems. To master this objective, begin at part A and work your way through to part D. If you try to do part D without understanding what happens in part A, you wouldn't be able to do it. So we finish part A, we finish part B, we finish part C. We are now at part D of this same one objective, and we will be looking at some other polygons like octagon and heptagon, pentagon, and other regular polygons, and then one irregular polygon. So we are here, construct other polygons. We are now looking at octagon. After the hexagon, the octagon is the next easiest. So that is the one we will be looking at now. Recall what we said about these shapes. If we have a box here and we were to place all polygons in it, we will have triangles first of all, various types of triangles. Then we will have quadrilaterals, various types of quadrilaterals. Then we will have other regular polygons with 5 or more sides, example pentagon, hexagon, octagon, and so on. We will also have irregular polygons with more than 3 sides. So far, we have already dealt with the hexagon. So now we are going to continue with the octagon. Octagon here, it has 8 sides, and that base angle is 67.5 degrees. We don't know how to construct 67.5, but we know how to get to that. So the principle we are using is we will construct the angle if we can, like 60, and then this one 67.5. If we can't construct the angle, we will find a way around. If we can't find a way around, we will calculate height to the center from the base, and if all of that fails, we will be forced to use a protractor to measure these base angles over here, to measure them for example, 70 degrees. So we will learn some principles. So let's continue with the octagon. Construct a regular octagon of sides 4.0 centimeters. So that's the octagon. Side is 4.0 centimeters. This is what we are heading to. By the time we finish, this is what our drawing will look like. Octagon has 8 sides. So this angle down here is 67.5 degrees. This angle down here. Can we construct that? No, but we can construct 135 and then bisect it. So that is what we will do. Remember, we want to find this center here. From there to A will be the radius of the circle, and then we will take AB and mark that off on the circle. So let's see how we arrive at that. So first of all, we construct the base, AB 4.0 centimeters, and we construct a perpendicular bisector to that base, which is this. Next, we construct at this point 135 degrees. We will then bisect it to get 67.5. So we will bisect this 135 from there to there. It's 135. We will bisect it like that using this point here, and that we will open the compass fairly wide, draw a line through there, that there. So this is 67.5. We project that angle until we reach here. So 67.5 reaches that perpendicular bisector at C. That will be the center of the circle that we will draw and mark off AB on the circle. So from here, C to here or here, we will make a nice circle around there. So we get this circle, and now we will take our compass, open it to AB, which is 4.0 centimeters, and make marks on this circle. However, before we do that, we will extend this side here, and coming from A, we will extend that through to that point as a precaution, like that. So since this is an 8-sided figure, we already know that that will be one of the sides. So we take this measurement, 4 centimeters, we mark off here, there, and there. Note where it falls. We come from this end, mark off here, here, and there. Note where it falls. So we have this. We are almost finished. All we need to do is draw bold lines connecting these points on the circumference, like that. And we have just constructed an octagon, including the use of this angle here. So we didn't have to use protractor. We can actually construct that angle. Construct a regular octagon of sides 4.0 centimeters. So let's draw a construction line. Measure 4 centimeters. Near this end, place the metal point and make an arc like that. And then where that arc intersects this line, make another arc like this. Bold this piece of the line. .0 centimeters, and that's the base of the octagon. Next, we want to construct a perpendicular bisector here. And now you draw a construction line here. It's a very thin line. At this end, or that, we will construct 135 degrees, then bisect it to get 67.5. So this would be a straight angle, 180 degrees, keeping this same measurement from here. That will be 60 degrees and this will be 120. Bisect this 60. To get 30. At that point, we will bisect this 30 to get 15 at this point. And now from here, that's 15 and 120, that's 135. We will bisect this 135 to get 67.5. And that would be the center of our circle. That measurement there, which is the same measurement here, this next step here is not really necessary, but it's a precaution. Now all that remains is to make sure we have this 4 centimeters. From here, 1, that, and this. And then we draw bold lines connecting these points. And this is our required octagon. 1, 2, 3, 4, 5, 6, 7, 8. Sometimes when you get to the top here, you would be a little off. If you find this video useful and interesting, please like and share. That is to say, like and share. You may also consider subscribing to this channel. So now let's deal with the heptagon. We finished with the octagon. That wasn't very difficult. This one is a little more problematic, but we can find a way around it. So we are here, heptagon. We finished with hexagon, we finished with octagon. This is a 7-sided figure We want an angle of 64.3 degrees at the base of the internal triangle. We don't know how to construct that. We can't work around that. So we cannot construct that. So we will find a workaround. We'll find a way to work around it. And I will give you a little hint right now. You know how to find the point for six-sided, 60. You know how to find the point, the center point for eight-sided. This seven-sided here, it should be somewhere between the six-sided and the eight-sided. So let's use that principle. So this is what we are working towards. Note please, this D here will be the center of the circle if we were constructing a hexagon. And this E here will be the center of the circle if we were constructing an octagon. What we have to do is bisect DE to get F and use that as the center of the circle for the heptagon, which is what we are going to do. So when completed, this is what we are aiming for. Seven side, as I said, we know how to find the center of the circle for six sides. We know how to find the center of the circle for eight sides. We will find those. We will divide the space between those to get for seven sides. We don't know how to construct 64.3, so we find a way to work around it. So we construct one side, the base, AB, and we construct a perpendicular bisector to it. This is what you have here. Next, we will find the point for eight sides, which is 67.5 degrees. So we want an angle of 67.5 degrees. Where will that intersect with this perpendicular bisector? We know this is 135. We will bisect it. We will bisect from here to there, and we get that. That will be the center of the circle if we were going to draw an octagon, 67.5 degrees. Then we could come from this end, or we could continue from here, construct this 60 degrees, which would give us the center for the circle to construct the hexagon. As we could see, that will be 60 degrees. This one here, 67.5. Let's see that closer. That for eight sides. This for six sides. So the space between here and there, we are going to bisect it and take somewhere in the middle here. So eight sides, six sides, bisect it, and we will get this. Hopefully that will work for C7. So we can easily get that. We can get this, not too easily, but we can get that. If we bisect that line from there to there, we will get this. And hopefully that will be the center of the circle for the heptagon. If we measure it with a ruler from there to there, we could see this looks like it is about halfway. Now, if we calculate the distance from the center of that base to the center of the circle for a six-sided figure, if we calculate this length using trigonometry, which we will learn about later, we find that it is 3.464 centimeters. So from here to here, and this is another way that you could find that center, by calculating how far it would go up this perpendicular bisector. So that was for six sides. If we do the same thing for eight sides, we find that we get 4.828 centimeters. Here, this length here will be 4.828 centimeters. So let's calculate what it will be for seven sides, which is actually 64.3 degrees. If we didn't have any other way, and we don't want to use that protractor there to measure 64 degrees, we can use trigonometry to calculate the height that this center would be along this perpendicular bisector. and we get 4.156 centimeters. Okay, let's put all of those together and see where this center for the seven-sided figure falls. So if you put them all together, that would be for 6, that would be for 8. Notice where this one falls, for 7. If we use the trigonometric ratio to calculate the height, which is the tangent. So from there to there is 0.672, and from here to here is 0.692. Not much of a difference. A 0.02 centimeter, which is 0.2 of a millimeter. That is less than the pencil that you are using to draw these lines. So we can comfortably find that bisect it and find this. So we don't have to use trigonometry, and we will not have to use the protractor to measure 64 degrees. So this is seeing it closer. There's not much difference from that was C8, this is C6, and that by calculation is C7, the center for the circle, to draw the seven-sided polygon. So let's use that and see how it works. So this one here, remember 135 bisect it, and you get that is the center for the circle for 8 sides. This one here, 60 degrees come up here. That's the center for the 6-sided figure. We bisect ED and we get F. Let's use F as a center for the 7-sided figure. So we place the compass at F, the metal point, extend it to A and make a circle. We get that. On that circle, we will mark off AB going that way. Since it is 7 sides, project this because you would have to end up at that point there. 7 sides. So you take AB and make some markings here and mark it off on that circle. So this is what you get. AB, and from B you make that mark and then that one and then this one here, and then come from this other end, you make that mark, this one and this one. Notice the two of them should meet at that point along this perpendicular bisector. Once you have that, you just connect these points on the circumference, and this seems to work. We can live with that. We have just constructed a regular heptagon of sides 4.0 centimeters without the use of a protractor. This is looking at it a little closer. If you take the protractor to just verify what was happening, you could see there, and here, which we got by bisecting DE. We also got that point if we were to measure the angle of approximately 64. So this is just verifying that we were on the right track. That's the angle, and this is the bisector of DE. Same point for the center of the circle with that on which we are going to mark off the heptagon. Construct a regular heptagon of sides 4.0 centimeters. A construction line, measure 4.0 centimeters. From near this end, you can arc like that. Change over here, make an arc like that, bold that piece of the line, next thing we want a perpendicular bisector at this point. We can maintain this same measurement because we know up there will be for 6. And that is our perpendicular bisector. Let's just double check it. Okay, 90 degrees.